Okay, ladies and gentlemen, as you can see now, you can see that our contactor, timer, voltage switch or voltage monitor, and our breaker, all of them are now in our box. All of them are now in our box, and this is actually our neutral or our earth terminal. So you can use it either for your earth terminals or for your neutral, anyone you want to use it and do. So this is it. So the contactor is actually does the switch. You call them active element in automation, active element in components of automation. While the timer, we call it decisive element in component of automation. The voltage monitor, we call it an integrated circuit under decisive element in components of automation. While the breaker is also a decisive element in components of automation. Why do we call them decisive elements? They vary the current or the voltage that passes through them. If it's permissible or if it's something that they need to pass out, they will pass it out. If it's not something that is within their permissible range, they will not allow it to cross. That's why we call them decisive elements. While active element doesn't have any sensoring device, they don't have anything that detects or signals danger. So even if it's a power that is not okay, they can still pass it. But what decisive element does is to know whether those powers or those currents or the voltage or whatsoever is okay before they can allow it to pass through them. So having said that, we're going to making our connections. Okay, so we're about to make our connections. Now this is how our connection will go. This is our breaker. Our breaker is supposed to control the power that comes in. Now specifically for the utility supply, specifically for our utility supply. So I'm going to plug out this guy here. Let me plug it out. So we'll be needing it later, but not now. So let me plug it out. So our breaker is going to have to deal with the supply that goes here, so that if there should be any mishap, it should go off. Also, the voltage monitor, we are putting it on our low side. We were putting it on our low side, so if the power supply is not okay, it's not going to go down to our low side. So the power that comes out from both the gen and the NEPA is going to go to the voltage monitor and then leave. So ideally, probably some people might use it to for the supply, but in this case we have two supplies, so it's not necessary to put it on only one supply, in as much as we're even using the breaker to rotate one of the supplies. So what we're going to use this voltage monitor to do is to manage and then protect the loads that goes to our components. So let's start. So we are going to make the cables you are using are not rated, so please, before you start building any automated device, please go back to all the resources that we've actually created, that as it concerns to how to take proper load audit, how to size your cable, how to size your components, how to size all those things are in introductions to automations book. So before you start building, carry out that particular activity, so as to make sure that you understand the size of wire to use when you are automating. In this case, we are just trying to use any of the rough wires we have to do that. But in your own case, please carry out proper load audit. From the proper load audit, ascertain the size of the size of the components to use and the size of cables to use, using the current carrying capacity formula or table. Thank you. So what we are going to do is, since this is our supply, we are going to take our cables from okay. Okay. So we will now take it to our load will be up. We'll take it to our coil terminals. Okay. Let's see whether we can take that from down. Yeah. We'll take it down. So let's leave it. Bring our supply cable. one will go to the breaker. We are taking this to be our utility supply. One will go to the breaker, while one goes to one one will go to the breaker, while one goes to um our supply. So in this case, our our power is in normally is in the normally open terminal. If you look at the diagram, you see that our lines cable came into line 1 and line 2, which is normally open to T1 and T2. So that's the same connection we are going to be making. Okay. Okay. So in this case, we are using 13 and 14 since it's normally open terminals. We are using 13 and 14 since it's normally open terminals. So okay. So remember, we had another cable that went from the T1 and T2 to the relay. We have a cable that went from the T1 and T2 to the relay. Now we're going to be having two loads. Prepare two pilot lamp. One will be to represent the alarm, and the other will be to represent our load. So we took power and supply to 2 and 7 of them. Okay, we connect to 13 and 14, which is normally open. 13 and 14, this one is 42 and 44 and 43, which is normally open terminals of a contactor. So we'll connect this one to 13 and 14 as well, which is normally open terminals of a contactor. Remember, the top is actually where we will be taking our load out from, our output from. And we as well know that our load will be taken from both the generator power and then the NEPA power. So let's quickly make connection to 2 and 7 of our timer. So remember, as we're making that connection, we are as well connecting to the coil terminal of our contactor. Let's not forget, please, that we are as well connecting to the coil terminal of our contactor. We are connecting to the coil terminal of our contactor. We can do it either ways, either connect to the coil terminal of the contactor before going to the timer. So A1 and A2 are the coil terminal of our contactor. A1 and A2 are the coil terminal of our contactor. So I'm connecting to A1. So from A1 it goes to number 2 of our from A1 it goes to number 2 of our coil terminal. From A1 it goes to number 2 of our coil terminal. Okay? Sorry, our wire stripper is not close. Okay? So it goes to number 2 of our relay terminal. Okay? Then from from A2 as well, it will go to the coil terminal of our from A2 is down here. A2 is as well down here. I'm connect from the top or from the down. For convenience, let's connect from the down. Okay, so from here we connect to the number 7 of the coil terminal of our timer. Number 7 of the coil terminal of our timer. Okay. Okay. So from the time coil terminal of the timer, we loop from 2 to 8. We loop from 2 to 8. 8 is down here. Look at number 8 here. 8. Okay. 8 is up here. So we loop from 2 to 8. So we loop from 2 to 8. Okay. So and make sure that all your connections are properly tightened and then they are strong, firm, so as not to have run the risk of having any loose connection. Please, it's very very important to make sure that all your connections are tightened very firm, so as not to have loose connections. Okay, so having said that, we will be connecting from 5 to our load. So our load is going to look something like this. This is our lamp, for instance. That's where we are connecting this first. This is our lamp. There will be a diagram for whatever we are doing so far. So if you can't catch up, just look at the diagram. You will still achieve the same thing. Look at the diagram, you will still achieve the same thing. So, because I know it will be looking more ambiguous the way you are looking at it. So we connect the red to number 5, which is normally close to number 8. 5, which is normally close to number 8. And then we connect back to 7, which is the neutral terminal of the coil terminal of a timer, which is the neutral leg of the coil terminal of a timer. So, okay. Okay, so let's look at our loads. Okay, this is what we are going to be using as our load. We are going to be using this as our load. So we said our load is going to be coming from the voltage monitor, so as to protect it. Voltage monitor, so as to protect it. Okay, so just quickly make the connections to our voltage monitor. So this is live. Okay, so having done that, we are going to connect the remaining our alternative supply. Okay, so we'll connect our alternative supply, which is what we can call the generator. Connect it here. So we are going to connect to the normally close of these terminals. This is AC, so we are not concentrating more on the polarity, but paying attention to the polarities is also very very important. Paying attention to the polarities is also very very important. Paying attention to the polarities is also very very important. Pay attention to the polarity as well while making your connections. Okay, pay attention to the polarity while making the connections. Okay, so having done that is to loop out our load. Loop out our load. So since this is our load, we are going to connect them together, loop the outputs together. We'll connect this to, first of all, anyone can go anyways, but our life. Okay, then we now loop it to 43, which is normally open. Remember, we are trying to loop our loads out. Okay, we are looping it out. So if you have done that, we said it's our neutral, so let's connect to here. Okay, always confirm that your connections are firm. If your if your copper cable is not touching the terminals, it's a very big issue. Okay, we connect to from the live cable down to, okay, so this is it. Okay, so we now connect, loop back the normally close and the normally open together. So in this case, we are connecting to the normally close first before the normally open. Okay, so we now connect the last cable to normally open. Okay, make sure that your connections are firm. Make sure they are firm. So if you have done that, let's close our trunking pipes. Let's close them up. Close them up so that to make it to look a little bit neat. Small neat. So remember, this is our alarm and this is our load. We assume this should be the NEPA alarm that we know. When power comes in, it will shout. When power goes out, it will stop shouting. Or when it shouts, it now goes up by itself due to there is no more power. So what we are going to do now is to power up our device, our automatic changeover. So we are going to test. Okay. So it's recommended that you test what you've done, because in most cases you might make some slight mistake. Then you need to confirm whether there are any mistakes you made so as to correct it on time. Okay. So once there is polarity, you should know there is a problem. Okay. So which other one? The neutral to the neutral, the life to the life. And then what the okay? Yeah, to the life. It doesn't. Pull our breaker up. Okay. Then what else should we test for? The way I want to coil terminal, our A1. Okay. All passed. Then our neutral to our neutral here. All passed. So we should just power off our device. Okay. So ladies and gentlemen, our timer is upside down now. But don't panic. Okay, so we are going to power on our device. This is our utility supply and is our generator or alternative power supply. Okay, so we have done our connection and this is actually the time for us to power it on. Let's recap a little bit. You understand that this is our utility supply and this is our alternate power supply, which can be generator or solar. Now our utility supply goes through the breaker before going down to our contactor, and also understand that the load has to pass through voltage monitor before going down. This is our load, and you'll be asking what this red light is doing. This is supposed to be a siren ideally, because in Nigeria we have what we call a NEPA alarm system. A NEPA alarm system actually sounds an alarm when NEPA comes in and then goes off when NEPA goes out. So we're actually trying to use it to represent a NEPA alarm because we're actually in a confined space so that we don't have an ear problem. So this NEPA red light represents our alarm system, while this represents our load. Then let's go on. Let's say for example that your generator, your generator is on, for instance. You can see that the generator power, this is the generator lines, it passes through this automatic changeover, which is already normally closed, down to the load, then from the load to down to the voltage monitor, then from the voltage monitor to our loads. You can see our load is on. You can see our load is on. You can see our load is on. Let me recap again. This is our generator power. Our generator supply goes through this line, which is normally closed, direct to our load side, which is on the voltage monitor. Then from the voltage monitor, you can see out here, from there to our load. Then if NEPA comes in, I need to switch up this breaker so as not to be having papa sound. So if NEPA comes in, this is our NEPA breaker. Once I flip it up, it changes the NEPA from NEPA to the generator. Watch. You can see this guy went in when I press it on, and then power changed over. And also you see that this guy is on, which is our NEPA alarm. It has gone off. So we are going to set, let me go off again. We are going to set this NEPA alarm at least for 10 seconds. Let's set it for 10 seconds. So when NEPA comes in, it takes off gen. You can see that the gen can go off and the light is still on. Then after 10 seconds, this guy should go off. It should go off in 10 seconds. It will go off. So our alarm has gone off, which is our NEPA alarm system. It has gone off, and then our load is on. Even without the generator being there, you can see that our load is still on. Then even if generator comes in, it doesn't affect the load. Why? Because the utility supply is taken over, has taken over the system. The utility supply is actually the line controlling the whole system. That's why we call it utility, because it's a power that we don't control, and it's actually controlling our light power. Then when NEPA goes off, I will use this breaker to illustrate, or as well even pull out from here. You can see that it has gone out, and there is still power here. Why? Because our NEPA generator is still here. When we take our generator, the whole system goes blank. Hope it's understood. So this is how to build an automatic changeover using one contactor, voltage monitor, breaker, and a timer. So this is actually how to build an automatic changeover that can switch into between sources of power using one contactor. In our case, we use both contactor. The timer is just serving for the NEPA alarm system, and we're using our decisive element, which is the breaker. Now if I turn off this breaker off, you can see that the power goes over to the generator and our voltage monitor is still on. So this is actually how to build automatic changeover using one contactor to change in between two sources of power. Thank you.